This meeting is being recorded.
In this next section of the Chapter 16 Acid-Base Equilibria worksheet, we're going to look at some acid-base properties of salt solutions. So you may be thinking salt solutions, generally they seem like they would be neutral because we know that salts are neutral. So, it's things like sodium chloride, that's a salt. But also strong acids, strong bases, weak acids, weak bases, things that are also considered acidic and basic can be parts of salts. So let's take a look at, say we have sodium chloride, for an example that I wrote out above. If we have a strong acid like HCl, and then we add sodium hydroxide together, we get a strong acid, right, and a strong base. We will get something neutral. We're going to get our salt and water. So NaCl, right? So chloride, sodium ions will rejoin, and water. So you can remember whenever you have a strong acid mixed with a strong base, we're going to have a neutralization reaction and our products will be neutral. Say we have a strong acid with a weak base, we're always going to end up with an acidic solution. So if you have a strong acid, by comparison, the base is weak, so hydrochloric acid with ammonia, we're going to get an acidic solution. The same applies if you have a weak acid with a strong base. You're always going to see a basic solution in the end. The only time when you have to look a little bit further would be, say, we have a weak acid and a weak base. We need to know pKa and pKb values to be able to solve for hydroxide and hydronium ion concentrations at equilibrium to see which we would have more of. But in general, you should be able to make these types of determinations. So another example of strong, say we have barium hydroxide. We know that that's a strong base, an SB, and then we have nitric acid. So we're going to see that we get a neutral barium nitrate salt as our product here. So this we would consider neutral, and of course H2O. This is unbalanced though. So again, notice if you have a weak acid or a weak base. So if we have, say, something like chromium hydroxide, which is a weak base, plus a weak acid, say we have HF. This is one of those scenarios where our chromium fluoride product, we're not sure unless we look up the Ka and Kb values. Is it going to be acidic or neutral? There's some other guidelines here that you can use when you're studying and on your test. Things like when you have an anion that's a conjugate base of a strong acid, this is neutral, such as an example of HCl, giving you the chloride ion. So these again are some other guidelines for how to determine whether or not a salt solution will end up being acidic or basic.